So, good morning children. Today, the same exercise 13.1 question number 7. So, this question is lengthy. You have to take your book. So, here they have given that the Sandy sweet stalls was placing an order for making cardboard boxes for packing their sweets. Two sizes of boxes were required. So here now they have given that Santi sweet stall, it was placing an order for making two types of boxes. One is the bigger box, second is the smaller box. So they have given their respective dimensions. So here for the bigger one, length is 25, breadth is 20 and the height is 5 centimeter. And for the smaller box, length is 15 centimeter, breadth is 12 and then the height is 5 centimeter. Now here they have given that for all the overlaps. So here the second part, because this part you are to know it. For all the overlaps, 5% of the total surface area is required extra. If the cost of the cardboard is rupees 4 for 1000 centimeter square, find the cost of the cardboard required for supplying 250 boxes of each kind. So the question is very lengthy one, that is why we will go part by part. So now first one is given that the shop has ordered 250 boxes, one is of the bigger one and the other is of the smaller one. So for the bigger box they have ordered 250 boxes and for the smaller also they have ordered 250 boxes. Now here they have given their dimensions. So for the bigger box they have given the length, breadth and the height. Also for the smaller box they have given the dimensions, length, breadth and their height. Now the remaining part, here they have given that for all the overlappings 5% of the total surface area is required extra. So if the cost of the cardboard is rupees 4 for 1000 centimeter square, find the total cost of the find the cost of the cardboard required for supplying 250 boxes of each kind. Now the shop has ordered 250 boxes of means both the kinds. That means the total boxes will be 500. Adding this to 250, that means 500 boxes the shop has ordered. That is to packing their sweets. So now they have said that 4 means all the overlappings, that is the extra cover. Extra means cardboard they will need how much? 5% of the total surface area. That means after finding the total surface area of this bigger box, that is twice of LB plus BH plus HL using this formula, then you are going to multiply that by 250 because the number of bigger boxes is means 250. Similarly, you are going to find the total surface area of a smaller box. So that is also by twice of length, breadth plus breadth, height plus means height into length, and then you are going to find the product with 250 because the number of smaller boxes is also 250. Now you will add these two. That means you are going to find the total surface area of the bigger box of 250 boxes. Also, you are going to find the total surface area of 250 boxes of the smaller size. Then you are going to add all these 250 boxes of both the kinds, their total area, and from there for all the overlappings, that is the extra coverage, extra cardboard, how much? 5% of the total surface area is required extra. So that means they will need 5% area of the cardboard extra. So if the cost of the cardboard is rupees 4, now they have said that for 1000 centimeter square, cost of the cardboard is rupees 4. Then now for this 500, 250 plus 250, so you have got 500 total boxes of the smaller kind as well as the bigger kind. So by adding their areas, that is the total surface area of 250 bigger boxes and that of the 250 smaller boxes, whatever total areas you will get from there, you are going to add 5% of the total surface area. So from the total surface, you are going to find out 5%, and that one you are going to add it because that is the extra. Then you are going to find the cost. If the cost of the cardboard is rupees for 1000 centimeters square, that means for every 1000 centimeters square, the cost of cardboard is rupees 4. So after getting the total area, including this 5% extra, that means this 5% you are going to find when after finding the total surface area of these 500 boxes, 250 of the bigger box, 250 of the smaller box. So after finding the total surface areas, you are going to add with that 5% the total surface area required extra. That is why, since this one is extra area of cardboard, you are going to add with the total this 5%, and then you are going to find the cost. So then they have told find the cost of cardboard required for supplying 250 boxes of each kind. So that means you are going to find the total cost of all these boxes, that is for the 250 bigger box and 250 smaller boxes. Now first let us find out their total surface area of the bigger box. So here now they have given that for the bigger box, so the length is 25 centimeter, breadth is 20 centimeter, height is 5 centimeters. So let us find out the total surface area of this bigger box. And as the shop has ordered 250 bigger boxes, after that you are going to multiply 250 with the total surface area of one box. Then you will get the total surface area of 250 bigger boxes. Next part, you are going to find the total surface area of a smaller box. Then the number of smaller boxes ordered by the shop is 250, and then you are going to find the product with 250, and then you will add the 250 total surface area of the bigger box with the 250 boxes of the smaller box, and after adding these two, from there you are going to find the extra area of cardboard. How much? 5% of the total surface area. So you are going to find out the 5% of the total surface area, and then you are going to add it with the total. Then lastly you will find out their cost. So now for the bigger box, so total surface area, so it's TS, total surface area of a bigger box, equals to twice of length breadth plus breadth height plus height into length. So equals to twice of length is 25, so 25 into 20 plus 20 into 5 plus 5 into, so height into length, so height into length, so 5 into 25 centimeters square. So equals to now 25, so you will get 500 plus 100 plus 125 centimeters square. So equals to 2 into, so 5, 6, 7, so 725, so centimeter square. So you have got here 25, 10, so 5, 2 into 7, 14, so 1450 centimeter square. Now, so here you got the total surface area, that means here this is your box, say the larger one, suppose this is the cuboid box, So like this, they are going to order to make like this type of box 250. So now here you got the total surface. That means all the 6 faces. That means all this will be made with cardboard. That is why you are finding the area. So you are finding the area because this surface, all this will be made with cardboard. That is why you are finding out the area of cardboard of one box. That is the total surface area. So like this, they are going to place order of 250 bigger boxes. So you got the surface area of a bigger box, that is of a single bigger box. Now they are going to order how many? 250. So therefore total surface area of 250 bigger boxes, so equals to, so one box area is 1450 into 250, so it is centimeter square. So here, so 1450 into 250, so here this zeros let's cancel it. So 5 into 5 25, 5 into 4 20, 25, so it will be 7, then 10, 9, then 2. So it will be 5, 2, 6, 3, and then 2 zeros were there. There were 2 zeros. So 3625. So it is 362500 centimeter square. So you have found the total surface area of 250 bigger boxes. You got 3625. So this much area of cardboard will be required for 250 bigger boxes, because they are placing the orders for the boxes to be made of 2 different kinds. One is the bigger one, second one is the smaller one. For both the boxes, they have placed orders of 250 each. That is why you have found the total surface area of a bigger box. You got this much, and then the total surface area of the 250 bigger boxes. So the area is 4. So you got 362500 centimeter square. Now you will do the same thing for the smaller box. So here again total surface area. So total surface area of a smaller box equals to, so it will be same, twice of LB plus BH plus HL. So equals to, so twice. Now for the smaller, length is 50. So 15 into 12 plus 12 into 5 plus 5 into 50 equals to 12. 12 into 5, 60. So it will be 180, then it will be 60, then 75 centimeters square. So equals to 2 into, it will be 5, then 7, 6, 13, 13 plus 8, 21, so 3. So you have got, so it will be 30, it will be 6, so 630 centimeters square. So you have got the total surface area of a smaller box. So for the smaller box, you have got 630. So like this, they have ordered 250 boxes to be made. So therefore, total surface area of 250 smaller boxes. So one smaller box area is 630. So similarly 250 smaller boxes, so it will be more multiplied. So 630 into 250, so centimeter square equals to, so here 63 multiplied with 25. So it is 1575. So it will be, there will be 2 zeros. So 00 centimeter square. Now they have said that, so you have found out 250 bigger boxes area of cardboard. That means your total surface area means you are actually finding out the total surface area of cardboard. How much cardboard they will need to make these two different types of boxes. So that means total surface area implies the area of the cardboard for making 250 bigger boxes. So they will need this much area of cardboard. And similarly, for the total surface area of 250 smaller boxes, they will need this much area of cardboard. Now let's take it for all the overlappings, 5% of the total surface area. So 5% of the total surface area is required extra. So above this, besides these two, so this two is the total surface area of 250 boxes of the two kinds. So now you will add the total surface area of 250 bigger boxes with the total surface area of 200 much smaller boxes. So you will add these two, and after adding these two, you are going to find the extra area of cardboard. How much? For all the overlappings, 5% of the total surface area is required extra. That is why from this total surface area of 500 boxes, so 250 plus 250, you have got 500 boxes. So from this 500 boxes, the total area of cardboard, you are going to find out the extra area of cardboard, which will be 5% of their total. Then you are going to add it with that, and then the cost. So area of cardboard from two types of boxes, one is the bigger one, other is the smaller one. So their total area of cardboard, so from 250 bigger boxes, area of cardboard is this much, and from 250 smaller boxes, area of cardboard is this. So you will be adding these two. So it will be 362,500 plus. So it will be 1575. So 157500. So you add 00. So you have got 5,20,000 centimeters square. So this much is the area of cardboard that will be needed to make the two different boxes, each containing 250 boxes. Now from this, for the packing, they will need extra area of cardboard. That is for the overlapping, which is called packing. Extra area of cardboard. How much? 5% of this total surface area. So from this total, you are going to find the 5%, which will be called the extra area of cardboard. So therefore, extra area of cardboard required. So they have said 5% of the total surface area. That means from the two boxes, you will add all the total surface area, and from this total, you are going to find out 5%, which will be all the extra area of cardboard. So 5% of 5,20,000. So equals to 5 by 100 into 520,000. So 2 zeros will cancel. So you got here 5 2s are 10. So it will be 26,000 centimeter square. This much of extra area of cardboard. So this will be needed just for packing. So this will be extra. So now, what is the actual area of cardboard that will be needed? This total with this extra. because this will also be needed. That is for extra area of cardboard. So now total area of cardboard including overlapping, that is the extra area of cardboard, so equals to, so this is the total area of cardboard from the two different boxes. That means here you have got 250 bigger boxes and 250 smaller boxes, so you have got their total area of cardboard. So with this total, so 5,20,000 plus you are going to add the extra. How did you get this extra? 5% of the total surface area. So this is the total surface area. So you will have 2600, so 26,000. So here you got now, so it is 520,000, then 26,000. So you got 546,000. That means 5,46,000 centimeters square. So this much area of cardboard they will need to make 500 boxes of the two types. So this much. Now you are going to find out the cost of this much area of cardboard. So they have said that if the cost of the cardboard per 1000 centimeters square is ₹4, then find out the cost of 5,46,000 centimeters square of cardboard. Now, cost of, so it is given the cost of 1000 centimeters square of cardboard equals to ₹4. So it is given. You are going to find out the total cost of 5,46,000 centimeters square of cardboard. So therefore, cost of 1 centimeter square of cardboard. So now the area is less, so the cost will be less. So 4 divided by 1000, you will divide. Therefore, cost of here, so it is given 5,46,000 centimeters square of cardboard. So the cost will be more, multiply. So equals to 4 by 1000 into, so it will be 546,000. So you will cancel this 3, so equals to rupees. So 4 6 are 24, 4 into 4 16, 18, 4 5 are 20, 21. So your total cost is 2,184. So this is your total cost. That is this much cost the sweet store will order, and then their total cost of payment will be this much. So they have placed two types of boxes to make using cardboard. One is the bigger box containing 250 boxes. Next one is the smaller box of the 250 boxes. So now from there you have found out the total surface area of cardboard of these two types of boxes, which you have got this much. And from this total, they have told that for extra area of cardboard they will need 5% of the total surface area. So you have found 5% of total surface area. This is for packing. Then next, so the actual area of cardboard that will be needed, how much? So with this total you have just added this extra area. So you got 546,000. Now you are going to find out the cost of this actual area of cardboard. So you got this much. Now the last one, so question number 8. So here, so it is given that Parveen wanted to make a temporary shelter for her car by making a box-like structure with tarpaulin cloth that covers all the four sides and the top of the car, with the front face as a flag, which can be rolled up. Assuming that the stitching margins are very small and therefore negligible, how much tarpaulin would be required to make the shelter of her car with height 2.5 meter and with base dimensions 4 meter by 3 meter. So here they have given, here it is given that the height is given height is given 2.5 meter, and they have given the base dimensions. So base dimension they have given, it is 4 meter by 3 meter. So that means if we take a base, supposing this is the base, so this is a length, this will be breadth. So it is length and breadth, so because they have given base dimension, so this will be length by breadth and this is the height. So now they have given that here Parveen wants to make a temporary shelter for her car. That means she will make one garage just to park her car. So there's and now in the question it is given that she will make a box-like structure. So she will make a box-like structure, which means tarpaulin. So she is going to make not with bricks, but she is going to make her garage using this tarpaulin cloth that covers all the four sides and the top of the car. So the upper part will be covered and the two front and the back and the sides. So here, so it is given that covers all the four sides. So four sides means the front, the back and the two sides and the top of the car, except the base. So the base, there she is not going to keep the tarpaulin. So in the base part, tarpaulin will not be used, but in the remaining 5 surface, because if you take the box, that will look like a cuboid. That is why the base that will be kept as it is, but the remaining 5 faces, there is the two side faces, the top and the front and the back, that will be covered using the tarpaulin cloth. So now they say that assuming that the stitching margins are very small and therefore negligible. So now she said that when the tarpaulin cloth she has used, the tarpaulin cloth that is going to be used, so the stitching margins that was done, it was so small that you can just ignore it. That means therefore negligible. Negligible means no need to take into account, no need to take into its account the figures. So that is why assuming that the stitching margins are very small and therefore negligible. So you need not count the stitching part. Why? Because the part is very negligible. So hence that will not be counted. Now they say that how much tarpaulin would be required to make the shelter of height 2.5 meter with base dimension 4 by 3 meter. So here they have given the dimensions. It is length, breadth and the height. Now, so Parveen wants to make a shelter for her car. How? So she is going to make this shelter using the tarpaulin cloth. So above and the two sides and the front and the back. So that is why that is the total faces that will be used tarpaulin will be 5 except the base. The base will not be covered with tarpaulin, but the remaining 5 faces. So the front face can be rolled up. That means it can be flexible. You can just roll it up and then you can fold it. So that means the front face as a flap means as a flap that can be rolled up. So then the front face is there, tarpaulin, the back face and the 2 side faces, and then above the top. So that is why you have got 5. Now you are to find that how much of tarpaulin cloth will be required to make this carriage. So now that means if this is the box, supposing this is your box, this is the box. So the base is not going to be covered with tarpaulin. So they are not going to use tarpaulin. They are going to use on the top. So here the tarpaulin will be there. Here I have cut it. This is the base. This is the base. So this base I have cut it. So here the tarpaulin will not be used in this one. But they are going to use the tarpaulin on the front side. Suppose this is the front. So here they can roll down. So that can be folded. So here there is the tarpaulin on the back of it. This is the back. So here the tarpaulin is going to be used, and these are the 2 side faces. This one and then this one. So here the tarpaulin is going to be used and on the top. So that is what so leaving the base where they are not going to use the tarpaulin cloth. So there are 5 remaining faces where the tarpaulin is going to be used. So you are going to find out the area of tarpaulin used to make this box-like structure. So that means you will take the lateral surface area. So the 4 walls, 1, 2, 3, and then 4. The 4 walls with the ceiling. So then you will get the actual area of tarpaulin. Now, for a box-like structure, so here length. So the base dimension 4 by 3. So this is the base. Base is this one. This is 4 meter. So this is length, and this is the breadth. So breadth will be 3 meter, and the height is 2.5. This is the height. So your length is 4 meter, breadth is 3 meter, and the height is 2.5 meter. So area of tarpaulin that will be required. So equals to. So except this floor, they are not going to use tarpaulin on this floor, but the remaining 5 faces. So that means we can say that the area of the 4 walls, which is called the lateral surface area, plus the area of the ceiling. So this one, ceiling. So now here, that means lateral surface area. So twice into height L plus B. This is the area of the 4 walls plus the ceiling. Ceiling is length into breadth plus the ceiling. So it will be length into breadth. Now twice into height. Height is given 2.5. Length is 4 plus 3. So 4 plus 3 plus 4 into 3. So here you will get 5.0. So 5 into 4 plus 3, 7 plus 4 into 3, 12. So it is meter square equals to 35 plus 12. So you got meter square equals to, you have got 47 meters. So that means 47 square meter will be the total area of tarpaulin that will be required to make this box-like structure. So why we have used this? Because this is because you have not counted the floor, because on the floor tarpaulin is not going to be used. So the tarpaulin is going to be used on the remaining 5 faces. One is the top, remaining 2 is the front and the back, and the other 2 is the side faces. That is why this is the area of the four walls. Twice side L plus B. This is called the lateral surface area, or in simple words, this is called area of the four walls, and this is the area of the ceiling. That is the top surface. So then you got 47 meters square. So thank you.